In this video, we're going to draw the Lewis structure for carbon tetrachloride. When drawing Lewis structures, the first thing we have to do is we have to count for the electrons that are responsible for the formation of the molecule. And by doing so, we need to count how many valence electrons we have. So what I'm going to do here is I'm going to make a little table of has and once. And I'm going to have a carbon, and I'm going to have a chlorine. And what I'm going to do is I'm going to go look at my periodic table and see how many valence electrons both carbon and chlorine have. Well, looking at carbon here, we find carbon right here on the second row is 1, 2, 3, fourth one over. So we know carbon has 4 valence electrons. And in the third row, we've got chlorine, so 1, 2, 3, 4, 5, 6, 7. Chlorine has 7 valence electrons. So we can say carbon has 4, chlorine has 7. Each one of these elements would like to have a complete outer shell, meaning that they want to have 8 electrons total. So now we've identified how many valence electrons we have and what they would like to have. So let's figure out how many electrons exactly we have. We've got 1 from carbon, and we've got 4 chlorines we have to take into account. So let's see here. We would like to have 40 electrons, but reality is we've got 4 times 7, which is 28, 29, 30, 31, 32. 32 electrons to get the job done of 40. So what can we use with this? Well, knowing how many electrons we have versus how many we want to have allows us to figure out how many bonds we need. The number of bonds we need is simply 40 minus 32, 8. We have to share 8 electrons. Well, one bond in a Lewis structure equals 2 electrons, or E minus. So that means 4 bonds. We need 4 bonds to join carbon and chlorine in order to get these atoms satisfied to having a completely filled octet. Well, the next step is to pick an element to be the central atom. And we've got 2 choices. We've got carbon or chlorine. And when picking a central atom, we always pick the least electronegative element. In this case, carbon. Carbon's the least electronegative, so it's going to be the central element. So we're going to have carbon, and then we're going to have it surrounded by 4 chlorines. And I'm just drawing a line here for each bond. So you can see I've got 1, 2, 3, 4 bonds here. So I've got my 4 bonds, check. I've used 8 electrons. Of the 32 I originally have, I've used 8, so let's see, that should be 24. So we've got 24 electrons remaining to be placed. Well, once we've got the bonds taken care of, we assign electrons to the most electronegative element. And the most electronegative element is, you guessed it, chlorine. And I'm going to erase those numbers there for clutter's sake. So we put electrons on each chlorine atom, and we're going to make sure that there's a grand total of 8 electrons surrounding each chlorine. So what I'm going to do is I'm just going to put 1, 2, 3, 4, 5, 6. And each chlorine wants to have 8. So I've got 6 and 2 more here for 8. So I've taken care of 1 chlorine. So I'm going to go ahead and do that for the others. And by the time I put on these last 2 lone pairs, that is 2 sets of electrons, so something like this is known as a lone pair of electrons. Once I put on that last lone pair, I have run out of electrons, so I need to make sure I've got the right number of electrons on every element, because the Lewis structure is dependent upon making sure all of these elements has their 8 electrons surrounding them in this particular molecule. So I've got a structure, but is it the best structure? Well, the best structure is going to have the greatest number of atoms with a formal charge of 0. So the way we go through and calculate formal charge, which I'm just going to represent Fc here, equals number of bonds whoops, let's redo that for a second, equals valence electrons minus bonds plus lone pairs. All right, so with chlorine, we know chlorine normally has 7 valence electrons. If I'm going to pick on this chlorine right here, I can see I've got 1 bond. I've got 1, 2, 3, 4, 5, 6 electrons in lone pairs, and 7 minus 1 plus 6 is equal to 0. So this chlorine has a formal charge of 0. In fact, all the chlorines here, since they're essentially identical, have a formal charge of 0, which is a good indication we've got the right Lewis structure. Now, let's go ahead and check our carbon. Carbon, the formal charge of carbon, is equal to 4 valence electrons normally, minus the number of bonds, 4, plus the number of lone pairs, 0, which is equal to 0. So the formal charge on carbon is also 0. So everything has a formal charge of 0. That means this is the best Lewis structure for carbon tetrachloride, which again I'll just draw right here real quickly. It's 1 carbon surrounded by 4 chlorine atoms. Each chlorine atom has 3 lone pair sets on them. And that would be our Lewis structure for carbon tetrachloride.